In the United States, the Farmall tractor became one of the most influential agricultural machines of the 20th century, shaping the way farmers worked across millions of acres. Introduced in the 1920s and developed consistently through the 1930s and 1940s, it was engineered with a clear purpose: to provide dependable power, long-term durability, and easy maintenance for farmers who often lived far from specialized repair shops. American agriculture demanded simplicity that worked, even under extreme pressure. A tractor that could run 10 or 12 hours a day without mechanical complications was more valuable than one filled with modern features. This mindset, however, contrasted sharply with European expectations. When the Farmall began appearing in Italy during the 1950s, it entered a region where agricultural machinery was evolving quickly. Italian farms were much smaller, often divided into irregular plots, and located on terrain that varied from flat lowlands to steep hillsides and narrow vineyard rows. Their manufacturers focused on compact machines capable of precision work. They invested heavily in advanced hydraulic systems, higher revving engines, and designs that emphasized agility, efficiency, and a modern appearance. Because of this technological trajectory, Italian farmers and engineers naturally compared the imported Farmall to the newest European models of the era. They judged its tall stance, its open engine layout, and its straightforward mechanical systems through the lens of their own rapidly modernizing industry. To them, tractors with clean sheet metal styling, compact wheelbases, and innovative controls represented progress. By contrast, the Farmall looked like a machine engineered for a different century. The perception gap grew larger as Italians examined its design philosophy. The narrow front configuration used by many Farmall models seemed dated compared to the emerging European preference for wide front axles. The simple transmission, built for longevity rather than sophistication, appeared old-fashioned next to Italian multi-range gearboxes. Even its famous ease of maintenance, the ability to service most components with basic tools, was misinterpreted as a lack of technological evolution. But this judgment overlooked a critical fact: the Farmall had been created for the challenges of American agriculture, not European conditions. In the United States, fields stretched for hundreds of acres, sometimes thousands. Farmers needed machines that could run reliably through dust, heat, and long operating cycles. They valued predictable performance and straightforward repairability, because downtime could threaten an entire season. The Farmall succeeded precisely because it was built to withstand these realities. In Italy, however, the assumption was reversed. Durability was appreciated, but innovation carried more weight. A tractor that lacked the newest features could quickly be labeled outdated, even if its engineering was exceptionally robust. Thus, when Italian farmers first observed the Farmall, their impressions were shaped not by its capabilities, but by its appearance and the expectations of the era. This moment, when American durability met European modernization, created one of the most striking perception clashes in farming history. What Italians initially dismissed as old-fashioned was, in reality, a machine designed around a different set of priorities: consistent power, long-term reliability, and engineering that favored endurance over elegance. To understand why the Farmall defied the outdated label, it is essential to examine its engineering philosophy. The tractor was never designed to follow trends or chase visual modernity. Instead, it represented an American approach centered on mechanical clarity, long-term dependability, and serviceability in remote rural environments. Every structural choice reflected these priorities. At the heart of most Farmall models was a low-revving, torque-focused engine. Unlike the high-speed European engines of the 1950s and 1960s, which often emphasized rapid acceleration and refined combustion characteristics, the Farmall power plants were built to deliver steady pulling force at lower rotational speeds. This engineering choice produced several advantages: reduced heat stress, extended component life, and the ability to maintain consistent power during long work periods. Farmers who spent 10 or 12 hours operating equipment needed engines that remained stable, predictable, and mechanically forgiving. The transmission systems further demonstrated this philosophy. While Italian manufacturers experimented with multi-range gearboxes and increasingly complex shift patterns, the Farmall relied on straightforward mechanical layouts. Its gear sets were often overbuilt, using larger bearings and wider gear faces than many competitors. This provided exceptional longevity and resistance to shock loads, especially important when operating heavy implements or working in fields with variable soil resistance. The simplicity of these transmissions also allowed for rapid repairs. In many cases, components could be replaced with only basic tools, a necessity for farmers who lived far from service centers. Another key feature was the Farmall's cooling system. The tractor's large radiator capacity and generous coolant flow were not signs of outdated design, but rather deliberate engineering decisions aimed at thermal stability. In the vast American Midwest, tractors frequently operated in high-temperature conditions for extended periods. A cooling system designed to handle these loads minimized the risk of overheating, a common issue in more compact European tractors that prioritized size reduction. Hydraulics followed the same logic. While not always as sophisticated as Italian systems, Farmall hydraulics were known for their reliability and straightforward maintenance. The lift mechanisms, valves, and pumps were designed for robustness rather than complexity. This made hydraulic failures rare and maintenance inexpensive, two factors that contributed significantly to the tractor's reputation for dependability. The Farmall chassis and frame construction also set it apart. Heavy cast iron components increased weight, improving traction and stability during plowing and cultivation work. Italian tractors of the same era often attempted to optimize weight for maneuverability, especially for vineyard and orchard applications. But in large American fields, weight was an asset. It allowed the Farmall to transfer engine power to the ground efficiently, pulling larger implements with less wheel slippage and delivering consistent productivity. One of the most misunderstood aspects of the Farmall's engineering was its open mechanical layout. To Italian eyes accustomed to enclosed bodywork and streamlined shapes, the exposed components created a sense of outdated industrial design. Yet for American farmers, this accessibility represented practicality. With essential parts visible and reachable, daily maintenance became faster. Checking belts, adjusting valves, lubricating linkages, or diagnosing mechanical issues could be performed without removing layers of sheet metal. This design approach minimized downtime and empowered farmers to maintain their own machines. In retrospect, the Italian perception of the Farmall as behind the times stemmed not from poor engineering but from a mismatch of expectations. European tractors were evolving to serve specialized agricultural environments, while the Farmall continued to serve vast open fields where durability, torque, and longevity mattered more than compactness or stylistic innovation. By examining the Farmall's engineering choices, it becomes clear that its reputation was shaped by context rather than quality. What appeared simple from the outside was, in reality, a carefully thought-out system designed to deliver dependable performance year after year. Evaluating the Farmall strictly through engineering diagrams or visual appearance never told the full story. Its true value became clear only when measured in real-world agricultural performance. Across the United States, the Farmall developed its reputation through thousands of workdays, countless acres of cultivation, and demanding operating conditions that pushed machinery to its limits. One of the most significant performance advantages of the Farmall was its ability to operate for long, uninterrupted hours. Many American farmers routinely reported daily workloads of 8, 10, or even 12 hours during peak seasons. The tractor's low-revving engine design meant that extended operation created less thermal stress, less component fatigue, and fewer lubrication issues compared to high-speed European engines. This endurance was not theoretical. It was documented through decades of field reports and agricultural surveys conducted throughout the 1940s, 1950s, and 1960s. In controlled field evaluations, the Farmall consistently demonstrated stable torque delivery even under heavy load. When pulling moldboard plows, cultivating deep soils, or operating belt-driven machinery, torque stability was often more valuable than high horsepower figures. American agricultural institutions frequently highlighted this characteristic in comparative performance tests. While European tractors sometimes offered more compact dimensions or higher engine speeds, the Farmall excelled in tasks requiring steady, sustained force. Operational simplicity also improved real-world results. Operators could quickly adjust implements, shift gears, or perform routine checks without interrupting productivity. This reduced downtime significantly. Farmers in remote regions, sometimes miles from the nearest mechanic, depended on this reliability. A tractor that could be kept running with basic tools and minimal spare parts created measurable economic value. Fuel efficiency was another documented strength. Independent studies from several universities during the 1950s demonstrated that the Farmall's low-speed engines often consumed less fuel per acre worked compared to more sophisticated European designs. The combination of steady torque and efficient gearing allowed the tractor to maintain traction without unnecessary throttle increases. Over a full season, this translated into substantial cost savings. The chassis weight distribution also contributed to superior field performance. With a heavier cast iron frame, the Farmall achieved excellent traction on loose or uneven soils. European manufacturers, focusing on maneuverability and compact form factors, often produced lighter machines. While advantageous in hillside agriculture, this reduced traction in deep or dry soils. Comparative plowing tests from agricultural institutes in both the United States and Europe consistently showed that Farmall models experienced less wheel slip under load, improving both efficiency and implement control. Even the much criticized narrow front configuration proved effective in many applications. Although later phased out as broader front axles became standard worldwide, the narrow front format offered tight turning radiuses ideal for row crop cultivation. In large American fields, where tractors frequently navigated long crop rows, this improved maneuverability without sacrificing pulling power. Maintenance records further reinforced the tractor's real-world performance profile. Historical service data from farms across the Midwest indicated unusually long operational lifespans for critical components. Engines, transmissions, clutch systems, and hydraulic components often exceeded service life expectations by several thousand hours. Many Farmall units remained in active use for 20, 30, or even 40 years, a longevity that became part of the tractor's identity. When Italian farmers eventually began putting the Farmall to work in their own fields, many of the earlier criticisms quickly lost relevance. Tasks that demanded steady power, such as deep tillage, heavy cultivation, or pulling multi-bottom plows, showed exactly why the tractor had achieved legendary status in the United States. Despite being perceived as visually outdated, its performance under real workload conditions often surpassed European machines engineered with far more complex systems. Ultimately, the Farmall's real-world performance validated its design philosophy. Its combination of predictable power, mechanical accessibility, and operational endurance demonstrated that agricultural productivity depends not on modern appearance but on consistent delivery of work. The long-term legacy of the Farmall tractor cannot be measured only by its production years or by the technological standards of its era. Its significance emerged gradually, through decades of continued operation, historical reassessment, and the growing recognition that agricultural engineering must always balance innovation with durability. What began as a machine labeled outdated by certain European observers ultimately became a benchmark for dependability across multiple continents. In the United States, the Farmall became synonymous with generational continuity. Many units worked for 20, 30, or even 40 years, with some models remaining operational for well over 6 decades. This longevity shifted the way farmers and historians viewed the tractor. Instead of considering it a product of the 1920s or 1930s, they began recognizing it as a machine engineered ahead of its time in terms of practicality, serviceability, and mechanical lifespan. Italy experienced a similar shift, though it happened more slowly. Initial skepticism, fueled by design differences and contrasting agricultural needs, gradually gave way to respect as Italian operators accumulated real-world experience with the Farmall. tasks requiring stable torque, predictable behavior under load, and long operating cycles revealed strengths that were not immediately visible from its appearance. Over the years, many Italian farms kept their Farmall units in service alongside more modern tractors, turning to them whenever reliability and endurance were essential. Agricultural historians later identified the Farmall as a defining example of functional engineering, a design approach centered on tangible performance rather than technological sophistication. Studies comparing tractors from the mid-20th century frequently highlighted the Farmall's mechanical simplicity as a clear advantage. Fewer components meant fewer potential failure points. Larger gear faces and heavier castings translated into longer service life. And the open mechanical layout reduced the time and cost required for maintenance, a factor that modern machines often complicate with enclosed bodywork and electronic integration. The Farmall's legacy also extended into the collector and restoration communities. Because many units continued to operate reliably for decades, large numbers survived into the 21st century, allowing enthusiasts to preserve and study them. Restored Farmall tractors today demonstrate the durability of their original components. Engines still capable of smooth operation, transmissions still shifting cleanly, and hydraulic systems that continue to function with minimal refurbishment. This preservation reinforces the tractor's reputation not as an outdated relic, but as an enduring example of robust engineering. In academic circles, the Farmall is frequently cited in discussions of agricultural mechanization. Researchers analyzing the evolution of farm equipment emphasize how design decisions reflect regional needs. American tractors like the Farmall were shaped by large-scale agriculture, extended work cycles, and the necessity of self-service repairs. European tractors of the same period were influenced by dense landscapes, specialized crops, and emerging mechanical innovation. Neither approach was inherently superior. They were simply tailored to different environments. The initial negative perception of the Farmall in Italy eventually became a case study in how cultural context shapes technological judgment. Modern farmers who operate surviving Farmall models often describe them using terms that highlight consistency rather than innovation. Dependable, predictable, easy to repair, strong under load. These qualities remain highly valued even today, in an era dominated by electronics and automation. The tractor's long-term relevance demonstrates that agricultural machinery does not need to be technologically complex to make a lasting impact. Sometimes, simplicity executed with precision becomes more powerful than the latest features. The Farmall's ultimate lesson is clear. Real work does not depend on appearance or trends. It depends on engineering that stands the test of time. What some Italian farmers once dismissed as outdated eventually proved itself through measurable, repeatable, and undeniable results in the field. The legacy of the Farmall lives not in claims or opinions but in decades of performance that continues to influence how agricultural machines are designed, evaluated, and respected.